today's math lesson is division practice. It's lesson 5.5. You need to get your journal set up like this using the colors. I used a cerulean, which is a blue, and orange. And you need to get your journal set up like this. So push pause on the video until you do. One thing I want to make sure you do is that you've put the date in that blue empty box. Make sure you have today's date. All right, you should have written the words dividend, divisor, quotient, and remainder. We're going to go through and just as we're practicing for division, we want to make sure we understand what all of these vocabulary words mean for division. So we're going to define each one and kind of show what it looks like. So a dividend is the number that is to be divided or taken apart. The number that is to be divided or taken apart. So the dividend is the number that's on the inside. So what we're going to do is we're going to show that. Doing a long division house. We aren't using place value sections to show this. We're just going to use the standard division method. The dividend is what is inside. That is the dividend. The number that is inside. Okay, the divisor is the number that you divide by. Or the amount of groups, like you're putting groups of 9. So I'm going to put this in quotation marks, groups of. If I'm dividing by 9, I'm making groups of 9. If I'm dividing by 12, I'm making groups of 12. So it's the number that you divide by. And that is found out to the outside of the box and to the left of it. So let's draw the box again. But this time, it's the number that's on the outside left. So it's right here. Outside left. The outside left. So I'm going to take my orange and just kind of color that area a little bit lightly. So we have the dividend that's on the inside. We have the divisor that's on the outside left. And now we're going to talk about our quotient. The quotient is the answer to the division problem. That's what the quotient is, or it's how many groups of the divisor you were able to make. So it's the answer to the division problem. I'm going to put in quotation marks, it's how many groups you could make. So the divisor is groups of, it's the size of the group. Maybe I need to come back up there and write size. And the quotient is how many of those groups you could make, okay? So where do we find the quotient? Do you know? It's on the top. Good job if you're able to say that. The quotient always comes on the quotient line or at the top. That is where you'll find the quotient. And lastly, we have our remainder. What is a remainder? A remainder is the amount left over at the end of division. So it's the amount that you cannot fit into a group because you didn't have enough, right? So it doesn't fit into, or there's not enough to make a whole other group. So we're going to just kind of say this underneath it. So it must be smaller than or less than the divisor. It has to be that. And it is the amount left over that won't make another group size. Actually, we're going to say that won't make another, and then I'm going to put in quotation marks, group of. It's kind of, I guess it's a little confusing, but it makes sense if you think about where it's at. So at the very end, if you have some that are left over, it can't be more than the divisor because you would be able to make another group of that, right? So it has to be smaller than the divisor because you won't have enough to make a group of again. So where do we usually see the remainder if we're doing a division problem? Where does the remainder usually come in? Is it in the inside? Up here? No, that's where the dividend is. To the left is the divisor. On top is the quotient. So where is the remainder found? It is found down here, usually on the bottom right. So we usually see it down here on the bottom right. Because as we've been doing the subtraction, we're going to find it down here on the bottom right. Then when we find it, we bring it up and we use it. We put a little r when we put the remainder, or we can change it into a fraction, or we can even change it to a decimal, right? So those are the basic definitions for division and what is happening. So we're going to do a division problem, just basic underneath here, and then we're going to review how to change a remainder into all the different things that we know how to do. That's just going to be our review today. It's pretty quick. So let's go ahead and try a problem. The problem will be 7,003 divided by 5. So if the problem is 7,003 divided by 5, I know what the dividend is and I know what the divisor is. I do not know the quotient and I do not know the remainder yet. So let's go ahead and just kind of point or write out where the dividend is. Which one of these numbers is the dividend? Put your finger on it in 3, 2, 1. Did you put your finger on 7,003? You should have. That one is the dividend. So we're going to just write it above. That's the dividend. And what would you call the 5? The divisor. That's what you're dividing by. So let's set that up. We're just doing the long division method. I want everybody to solve their problems like this right now. Solve this problem like this. You don't need commas. If it bothers you, you can put it in, but you don't need to. All right. So we start with the first one. Will 5 go into 7? Yes. So you answer that on the quotient line. 5 goes into 7 one time. So you put a 1 on the quotient line. And then what was 5 times 1? That was 5. So you subtract that from 7. You bring down the 0. And you start the process all over again. But you look down here at the new leftover. Down here. You don't look up here anymore. You're looking at the new number. So I say, will 5 go into 20? Yeah, how many times? 4 times. And because I'm asking, yeah, how many times? When you give that answer, it goes on the answer line, which is the quotient line. So yeah, how many times will 5 go into 20? 4. So you put a 4 up above, you multiply to get 20, and then you subtract. When you subtract this and you get 0, it's not like you're done. There are still other numbers to bring down. So I bring down the next number. And I start the process over and ask myself, will 5 go into 0? No. And if I kind of smirk like that and say no, it means that there's a 0 in my answer. 5 5 will not go into 0, so put a 0 in your answer line, and you bring down the next number. Start over. Will 5 go into 3? No, so it's another 0 up here. What was 5 times 0? It's 0. You have to subtract, and there's no more numbers to bring down. So I have an answer of 1,400, remainder 3. Will you write remainder by that 3? The reason why it's a remainder is because I can't make another group of 5. Remember, the divisor is groups of. So if I get a leftover down here, and it's 3, I can't make another group of 5, so it is my remainder. It works. It's smaller. It works. So I'm going to just circle it, show that arrow going up, and I write remainder 3. That's what you would write for your quotient. Show it as a fraction. 3 is the numerator, and what's the denominator? 5. That is also the answer. Everyone doing okay with where all of our different numbers are? Okay, this should just be a really simple review, right? Well, we're going to take that same exact problem and review how to convert our remainders into decimals. So let's go ahead and just draw a big open arrow. Sorry, that is a really weird looking arrow. Struggle is real for me right now. There it is. There's an arrow. And I'm going to make it blue. What we're going to put in this arrow is how, well, I'm actually won't fit it in there, so I'm just going to write it on the bottom of it. How to convert, it means to change, remainders into decimals. Remember, that will just be a review because we have already learned it. Color in your arrow and turn the page. All right, let's take that exact same problem. 7,003 divided by 5. And let's solve it all over again. 5 goes into 7 once. 1 times 5 is 5, so you minus it from 7, and you get 2, which is good because that you can't make another group of 5, so I did that part right. And I bring down the 0. Start over. 5 goes into 24 times, and 5 times 4 is 20. So I subtract that, which is 0, which is good. I can't make another group of 5, so I bring down the next number. 5 goes into 0. It can't. 0 times, or none. So you have to put the 0 in the quotient line. And anytime you say, nope, it won't work, it won't go into that, you can put 0 in the quotient and bring down the next number. And then you start the process over again. Will 5 go into 3? Nope. So 0 in the quotient line and bring down the next number. There's no numbers to bring down. So you subtract, prove that the remainder is 3. Oh, wait. Silly me. We're doing the decimal thing. So do you remember what to do at this point? What do you do when you have this remainder? Okay, let's just go ahead and write the steps over here on the side. The first thing, after no numbers are left to bring down, So that's the situation that we're in right now. There's no new numbers to bring down. So after no numbers are left to bring down, put a decimal at the end of the quotient. Let's do that right now. Put a decimal at the end of the quotient. That's the first thing. The next thing, put a 0, I'm going to color it in a little, at the end of the dividend. So I'll go ahead and do that right now. What's the next thing we do? We drag that 0 down next to the remainder. So I drag it down next to the remainder. And then the next thing I do is start the process over. Actually, we'll just say start the division process. Let's go and make those bullet points be orange. And I'm going to read through them again. It says, after no numbers are left to bring down, put a decimal at the end of the quotient. Put a 0 at the end of the dividend. Drag that 0 down next to the remainder. Start the division process. So here's where we are. The division process is to look at the divisor and say how many times. So how many times will 5 go into 30? Or how many groups of 5 can you get out of 30? You can get 6. So 6, oh, I forgot to put this. You have to extend the quotient line. But it is 6. Wait, we got to add, extend the quotient line. Let's use blue for that to show what I just had to do. So where are we going to write extend the quotient line? Should we write start the division process? Maybe it's just the next bullet point? Sure. Extend the quotient line. Or it could say lengthen, but I think extend works. Extend the quotient line. Okay, so it works like that. So I go, how many groups of 5 can I get out of 30? I can get 6. So I extended the quotient line. I wrote 6 up here. And what was 5 times 6? You have to prove that it gets to 0. 5 times 6 is 30. So you subtract 30 from the made 30 to show 0. So my answer can be 1,400.6. All right, so the answer is 1,400.6. That was one way. Or it was on the back page, 1,400 remainder 3. Or it can be like a fraction, 1,403/5. Do you see where that remainder 3 came from? It was right here before we added that ghost 0. Call it the ghost 0. So that 0.6 one is the way to do it with the decimal. It's so cool. I love this so much. And now I want to do another problem where it's not just one time, like it's multiple. It's pretty awesome. You ready to try the next one? Okay, here it is. 4,458. That's the dividend. I'll just tell you right now. 4,458 divided by 54. Ooh. So we're using our double digit division skills as well. Okay, So we just do normal division until we get to the very end. Then we have to deal with the decimal, okay? 54 is a double digit. So I'm just going to kind of ballpark that and say, well, it's really close to 50. All right. Will 54 go into 4? No. Into 44? No. Into 445? Yes. How many times without going over? So I use the number 50 to help me. Remember? Count by 50s. 50, and put a finger up as you go. 50, 100, 150, 200. Should be at 4. 250, 300, 350 should be 7. 400 is 8. 450 is 9. That went too high. But it's really close. But there's no way it can be 9 because I was using 50s and it got too high. And I'm actually supposed to use 54, so it'd be way too high. So let's try not 9, but 8. Over here on the side, will you please do 54 times 8? It worked. So put an 8 in your quotient line above the 4, 4, 5, above the 5. So put an 8 above the 5. And it was 432. Subtract and bring down. So 13 worked because you couldn't get another group of 54. So that's a good remainder. Bring down the 8. And start over. 138. Count by 50s again. 50, 100, 150. That'd be too high. So it's got to be 2. So we're going to try 54 times 2 off to the side. I got 108. Could I get another group of 54 before it would get too high or higher than 138? No, I couldn't get another group of 54. So it is 2 in the quotient line, and you subtract 108. I get 30. So was that a good quotient answer? Yeah, because I can't get another group of 54 out of 30. So I did that right. So there's no more numbers to bring down. So I'm at this point. After no numbers are left to bring down, put a decimal at the end of the quotient. Let's go ahead and do that. Put a ghost 0 at the end of the dividend. Drag that 0 down next to the remainder. Ooh, so now it's 300. Start the division process. Extend the quotient line. I'm actually going to extend the quotient line right now. Okay, start the division process. How many times will 54 go into 300? Let's just use 50s. 50 times 6 would be 300. But 54 times 6 would be too high. So it's got to be what? 5. It's got to be 5. So let's try 54 times 5. 270. So it worked. So 5 in my quotient line, subtract 270. And I still have 30 left over? Oh man, that's what I had left over before. What do I do in this situation? You just keep going. You add another ghost 0. You bring it down. You start the division process over again. We know it's going to be 5 again because it's still 300. So 54 goes into 300 5 times. So 5 goes in your quotient line. We already know that 54 times 5 is 270. So we subtract 270, and guess what we're going to get again? 30. So what can we infer about this? That every single time it's going to be 30 left over, because it's only going to go into, even if I drew another one and brought it all the way down here, it's always going to be 300. Look at it, 300, 300, 300. Because 54 will only go into 300 5 times every time. So you're going to get a 5. If you were to keep going, you'd get 5, 5, 5, 5, 5, 5, 5, and it would never end. This is called a repeating decimal. So you do that really cool line over the top of it. It's kind of fun. And you get to write on this one, this is a repeating decimal. This problem that we just did was a repeating decimal. It's always going to be 5 over and over again. But you have to at least show it twice in order for, actually I kind of showed it 3 times. Because I even showed this third one. Oh yeah, it'd be 5 again. So you have to at least do it twice. Sometimes that third drop down will really prove it, but that is called a repeating decimal. That happens. I don't think it happens for you on your assignments, but I think it's good for you to know that you don't have to keep going. Or sometimes when you run into that, it's like, well, maybe I should have used then a fraction, or maybe I should have used just a remainder. But that's just how you do it with decimals. All right, in the next video, we are going to just take a look at your homework and remembering. So will you please find it before you start the next video? It's homework and remembering 5.5. We'll see you in the next video.